All right, hey everyone. Today I'll be presenting on my project Stream External Hydrophones on Orcasound website. So before that, a little bit about myself. I'm Karan. You can connect with me on LinkedIn, GitHub. I'm originally from Mumbai, India, and I'm a final year engineering student. I have a little over 1 year of experience in software engineering, and this year I was fortunate enough to come across Orcasound and explore Orcanode repository and the field of bioacoustics. Due to this, I got a lot of exposure to Python scripting, Docker containers, and shell scripting, and many other technologies. Currently, I'm learning more about cloud native technologies through open source contributions, and I'm hoping to continue contributing to Orcasound even after these. So a little bit about the project, a little background behind it. So for this project, we decided to study the slope-based shallow OOI hydrophone. It's a little farther away from the Oregon coast. And we decided to move forward with this particular hydrophone because we had a lot of data points in this one, and it was quite easy to test. So that was about the hydrophone, the hydrophone in question. The data which is captured by this hydrophone is stored in the OOI archive. The link has been provided here. So it is, as you can see, quite structured way of providing data. And this data is stored in MSEED format, which is quite popular among seismic community. But the thing is that it is not something that can be streamed on Orcasound website. That's where our project comes into picture. So, like I previously mentioned, Orcanode, this repository contains, the software contains audio tools and scripts for capturing, reformatting, transcoding, and uploading audio for Orcasound. Now, all these steps make use of a lot of open source technologies, and we'll go in each one of them step by step. So first and foremost comes the pulling or fetching data from OOI archive. The data, as I previously mentioned, is stored in mini-seed format. So that is pulled using OOI Pi library. It was originally built by John Ragnall, a student at University of Washington, and many Orcasound contributors have also contributed to make this particular Python library better. And I hope to contribute to this as well someday. So OOI Pi comes with built-in features that help us handle the gaps in data, which usually comes with archive data. So that was about the polling part, and it is locally organized in an organized directory structure. So before we move on to the next part, let me tell you something about HTTP live streaming, HLS. This protocol is used by us because it fits very well into our use case. In this, we have audio segments. It can be 5 minutes long or even more than that, and a playlist or a metadata file called as the M3U8 file. This particular file contains information about the playable segments, what is their length and what format and everything. So that is what we use to stream data on the Orcasound website. Transcoding data from MSEED format to something which can be played on Orcasound website like HLS segments is done using an open source tool called FFmpeg. FFmpeg also handles the creation of M3U8 files, so it makes our task a little bit easier. Upon transcoding the data into required format, we upload the data into Amazon AWS S3 buckets. And from there, it is used by the Orcasound website using the M3U8 file to give our users a near real-time experience of listening. There's another tool called Bitmovin, which we use in order to test our segments and the M3U8 file. So that was the work done up until now. Currently, I'm trying to run this entire code base onto some cloud services. So our initial plan was to go with Lambda functions, but we have switched to AWS Lightsail. After that, we plan to add integration tests using GitHub Actions for Orca node repository. So Dockerized tests and tests for the entire flow. Then after that, we also want to improve the documentation so that it becomes easier to onboard new contributors into our project. Yes, so that was it from my side. Feel free to ask your questions.